And it's not recording. It's recording. Oh, okay, all right, fine. So, you've got to be a little bit bonkers, a little bit passionate, a little bit not too serious about science to really love it, and also, to become good at it. You can't become good at, loving it. And I do. And this is physics, but it's also, way before we came along, said, look, this is physics, this is biology, this is chemistry. There was no separation. And the word alchemist is a very old word. And there was this whole thing, this whole obsession with, and this still is in society, which I think is a bit stupid. This whole obsession with making money, or this whole obsession of becoming rich. Um, Now I say it's a bit stupid, but that's my opinion. I'm allowed my opinion, and you're allowed yours. And because actually, no, I don't think it is, because so I don't mean like somehow my opinion is better or more correct than yours. I just mean that, in my opinion, being obsessed with money is a bit strange, and that's the feelings I get from it. And alchemists were. And what they were trying to do was change metal into gold. Even Sir Isaac Newton, one of the things he really wanted to do was change metals into gold. And he was looking at lead and mercury. That's probably why he went a bit bonkers as he got older. So alchemists were trying to make gold, right? Make gold. They were trying to make gold. And we're trying to make it from different materials. I should really rephrase that. They were trying to make it from different metals. And these are really cool because what's it got to do with isotopes? And here's a little bit of chemistry. Sometimes you'll have to use the periodic table of elements because this is nuclear physics and and it uses atoms and elements, and well, specifically atoms. So you've got to know a little bit about chem to do this in physics. So what is it? What were they trying to do? Well, gold is here, AU, all right? And they had this cunning idea to try to change something else to gold. Let me put gold. Do you know what? Let me put gold in gold color. All right. So this is gold. All right. Let me just put it. Let me just put it. Here's gold. And they were trying to make gold. And one way was trying to change mercury to gold. It's quite close. Or lead. All right. And as time progressed and we understood the periodic table and different scientists developed it further, went to Mendeleev and things like that, it became very evident, right, that if you look at the atomic number, what we also call the proton number, and this is 79. Gold has a proton number of, geez, that's big. Gold has a proton number of 79. It has 79 protons. Okay. If you change the number of protons to 80, it changes to mercury Hg. Well, what if you could do it the other way around? The problem is changing the number of protons. This is nuclear physics. In chemistry, we deal with electrons, bonds, and that kind of things, but this is nuclear physics. All right, fine. Now, I want to be very clear about this. If you change the number of protons, you change your element. All right? But what we're looking at today are isotopes. Donde esta? Where is the isotope? A little bit of Spanish. Donde esta isotopes? There it is. Isotopes. What isotopes are is you keep the same proton number. So if you look at gold, gold has a proton number of 79 and an atomic mass of 197, so 197 AU and 79. But this is not the only gold that exists. There's another type, all right? These are what we call isotopes. So what I mean by that is there is another gold that has a different atomic mass, let's say 198. But its proton number is still 79. You cannot change its proton number. If you change its proton number, then you change the element. So we have two different golds. We have 197, 198. And what does this mean? How can I think about it? Well, it means two things. I have 79 protons if you remember from chemistry and from last week, 79 electrons. They are balanced. They must equal each other. So that's nice, I'm working with gold. However, the number of neutrons is the atomic mass, 197, minus 79. All right. What does that give me? It's 118. I think it's 118, 79, so yeah, 118. So it's 118 neutrons. All right. That is for this atom. Well, here we've got something similar. Is gold? Yes, it is gold. However, it's got 79 protons, still the same. That doesn't say 79. 79 protons. And 79 electrons. But when we look at the number of neutrons, we've got 198, not 197, 198 minus 79. And the total number of neutrons we got now, dun, 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 is 119. Okay. Now I'm going to add something to this. All right. Let me change colour of pen. So I hope that makes sense. You can change the number of neutrons, but not the number of protons. Or you change your element. And sometimes you're going to want to change your element. So, 197. Okie dokie. If you look at both of these two isotopes, now remember they're isotopes because they have different number of neutrons. 190 neutrons. However, the number of electrons is the same. Therefore, their properties, how they react, how they behave, is the same. All right. So, key idea. All atoms of the same element have the same number of protons. Have to. But sometimes have different number of neutrons. These are called isotopes. Now, we expect you to know this definition here. Isotopes are atoms of the same element, have the same number of protons, and they must, but different numbers of neutrons. Now, this is really interesting. Oh, God, I can't even... Is it deuterium or tritium that makes heavy water? I'm sure it's deuterium. But anyway, or is it tritium? Well, hydrogen is H1. It looks like this on the periodic table, H11. One proton. This is the hydrogen that we always work with in chemistry. However, they have isotopes. So let's have a look at this. Hydrogen has one proton in the nucleus, one electron, right? That's because of this number here. But its mass number is 1. So 1 minus 1 is 0. It has 0 neutrons. Well, let's have a look at deuterium. H, little 2 there and little 1 there. If we look at it, again, it has one proton in the nucleus. It has one electron. But this time we've got 2 minus 1 neutrons. You have one neutron. I'll put an N there. And this is where all these numbers come. The electrons do not change. The protons do not change. But the number of neutrons alter. And that is the truth for isotopes. Okay. So what you get is the atomic mass is different. And an example that we use is chlorine, because chlorine is ace. Now, if you think about this, we go up to chlorine. I love chlorine as an example. Here it is. So what do you mean I love chlorine as an example? You know, what I love about chlorine is the fact that everyone goes about their daily business in science and chemistry stuff and doesn't really go, what? It's like, that's weird. How can it have an atomic mass of 35.5? But to you guys, you sit there going, well, that's not, I argue, why is that weird? I'll tell you why. Chlorine has 17 protons, 17 electrons whizzing around the outside. I'm not going to draw them all, I'm just writing 17 electrons. To work out neutrons, you do atomic mass 35.5 minus 17. That gives me 18.5 neutrons. Huh. Really? How's that work? How do you get 18.5 neutrons? How would you get half a neutron? Can't get half a neutron? Well, apparently I just have. I've got half a neutron. How do you get half a neutron? All right. You cannot. Right? There's no way you can have half a neutron. Okay, so this atomic mass is not just the number of neutrons plus the number of protons. It is the average. So chlorine, which is very interesting, all right? 75% of chlorine that we naturally find is Cl35. That would be Cl35 with a 17. All right. The other 25% is chlorine. Oops, where's my pen? Why can't I use my pen? What's going on here? Oh, you're being strange. Stop being strange. Why can't I write? Oh no, what's going on? Oh, I can't write. Why can't I write? Let's try again. Pen. Oh, well, that's it. Well, the whole board's just frozen. All right, let me just refresh it, darlings. I don't know what happened there. The board just kind of decided not to work. It's been a little bit funny today. Oh, take your time. I've got nothing better to do, have I? There you go. Let's try again. P for pen. I can't select pen. Oh. I can't zoom in and out. Right, I just stopped sharing that. Let me try again. Right, I can't zoom in and out. Well, I can zoom in and out now. Let's do P. I can't write. Why can I not write? Oh, that's 11 minutes. Well, actually, lucky enough, let me just stop that recording. That's near the end